the median. So I have to work my way into the middle. So I'm going to put my weights in order, least to greatest. And then I'm going to find the 12th weight. So you might be thinking, well, how did I get the 12th weight? So remember we said 23. So if I divide by 2, I get 11 with 1 remaining. So that means 23 has 11 to the left and 11 to the right with 1 in the middle. Odd numbers, it's easy to find the middle. Just like on our hand of 5 numbers, we can find our middle finger because it's odd. All right, so the 12th weight would be, if I put these in order, should be 6.6. There's 12 below and 12 above. And that's, all of these are in pounds. All right, then it said, would you use the mean or the median to summarize the data? So based on the information we said here, I'm really, really hoping that you said I would use the mean. Not mean, no, right? This is skewed. So I'm going to use the median. I'm going to use the median. Just kidding, right? Median. Because the distribution of pumpkin weights, anytime it says the word explain, I have to have context. Maybe modify that and add that in. The distribution of pumpkin weights is skewed right with 2 possible outliers. Okay, so hopefully that went fine. I'm assuming it did. So let's go ahead and think about our activity. Where do I stand? And make sure, if you didn't already do it, make sure you filled in your box plot. So this was one class. And so depending, this data is, going to vary, but this I think is my second class. I don't think it matters which class you were in. This one was decidedly shorter, and I think it's because there were more ladies in this class. So it says, well, the interquartile range is defined as quarter 3 minus quarter 1, also known as the IQR. So us mathematicians get sick of writing big words, so we abbreviate. So it's quarter 3 minus quarter 1. Where do you see IQR in the box plot? So I'm hoping you're noticing if this is quarter 1 and this is quarter 3, then it's the width of the box. Okay, so this is called a box plot, and this is called the box itself. The line in the middle of the box is the median, and then these are called the whiskers. So sometimes people call it the box and whisker, or sometimes just the word box plot. All right, now let's look at an outlier. Now, an outlier is a data value that is way too small or way too big. Are there any outliers? Okay, well, this is kind of arbitrary. There's a couple ways to figure out an outlier. Some is just by looking. But other times, some mathematicians came up with a rule of thumb. So this is maybe not a be-all, end-all, but in this class, we use it. And so it would be a way to say, I think it's an outlier because using this equation, it fits. So a number way too small is going to be quarter 1 minus 1.5 IQR. And way too big would be quarter 3 plus 1.5 IQR. So let's give that a try. In this data set, quarter 1 is 60, so 60 minus 1.5, and then our IQR, we didn't, so it said I needed to find it. So here, 67 minus 60 is 7. So we have 1.5 times 7 minus 60. So let's find out what that is. Let me just grab a quick calculator. So I get 49.5. And then now let's find a number that's way too big. So quarter 3 plus 1.5 IQR. So I get 77.5. So let me just double check. Yeah, okay. So let's see if we got this. Anybody that's greater than 77.5, no, I don't have anybody greater than 77. Anybody shorter than 49.5? No. We have no freakishly tall people and no freakishly short people in class. This guy in the picture looks freakishly tall. Okay, so at this point, even though we have 2 points out to the right, they're still not outliers. So are there any outliers? No, because no student's height is greater than 77.5 or less than 49.5. Okay, good job. Now, let's take a little notes, and then you can pause the video and try out the end. So, what are some important ideas here? The biggest thing I want to point out is what's called a 5-number summary. So, when data is skewed, we especially like to give a 5-number summary. That's your minimum, your quarter 1, your median, your quarter 3, and your max. That's our box plot. And those are the 5 numbers we use to make our box plot. So just to give an example, again, we had our minimum was 59, quarter 1 was 60, median 65, quarter 3 67, max was 73. So 59, 60, 65, 70, 73. Those are the 5 numbers I'm talking about. So in a box plot, that's all you see are those 5 numbers. And all the other numbers are just kind of ignored. So it's one quick way to kind of get a rundown where you don't have to look at all the data. So box plots are great if you've got thousands of data points and you're really not interested in any one data point. You're just wanting a quick bird's eye view summary. So what does an outlier mean? It either means a number is way too small or way too big, and I think most of us know that. But we're now learning today a way we can kind of calculate what would be a way too big number and what would be a way too small number. All right, and this was the equation we used, so I think it's nice to throw these in our notes because quick, our eye's gonna jump here to look for reference. And so then last, don't forget this, we wanna remember to check our shape, outlier, center, and variability when we describe our distributions and make sure we talk about our context. So that was from a previous class, and we can't forget to do that. Also remember, if I have 2 or more data sets, and here in my example I do, we want to be using comparative language. We're not just listing off their 5-number summaries and leaving it at that. We must actually analyze the data by comparison. Okay, so if you haven't already answered this question here, pause the video, try to give it a shot, and then hit play again. All right, guys, welcome back. Let's take a look. It says the following box plots showed total income of 40 randomly chosen households from these 3 states. Based on the U.S. Census data, compare their distributions of annual income of the 3. Okay, interesting. So I want to make sure I check off each step and bring in context. So let's do it. The shape, I'll start with the S, right? The shape of the distribution. And then why not do the context, get it right out. So it's the shape of the distribution of household income. Get my context right out of the bat. 4. So let's see. This one looks roughly symmetrical, right? Foldion Tapiani, if I folded it at the middle. So the shape of the household income for Connecticut is roughly symmetrical. While, right, these look like they're skewed. I can't fold right there, and I also have outliers. So those are going to be skewed right. While Maine and Massachusetts incomes are, now hold on, I'm going to compare these two, and as I look at that, hold on, it looks like Maine is slightly skewed, but Massachusetts is much more skewed. So I could even compare that. Well, Maine is slightly skewed, right? And Massachusetts incomes have a stronger right skew. Okay, so I've compared their shapes. It's hard to tell with a box plot, but pretty good. Now let's talk about the center. The center is highest for Massachusetts, right? Followed by Connecticut, and Maine, which have similar incomes. All right. Now let's talk about, oh, I didn't talk about the outliers. I should have thrown that in there, right? Outliers. Both Maine and Massachusetts have high outliers, while Connecticut does not. Okay, and the last one, V, variability. So now we've learned I can talk about the interquartile range. So I'm going to do that. Maine and Massachusetts the variability is highest for Massachusetts, right? The width of the box is definitely the widest for Massachusetts, while Maine and Connecticut have similar variability. Their boxes are similar widths. All right, thanks for joining me, guys. See you next time.